Okay, by the end of this presentation, you should be able to perform density calculations and use water displacement to find volume of an object. Density is an important physical property because it can help determine the identity of a substance. It's defined as the mass of the object per the volume. So it's an intensive property, meaning it does not matter how much of the substance you have. You can have 1 kilogram of aluminum or 1 gram, and it's still, the density should remain the same at 2.7 grams per mil. So here's the formula that I would highlight or box. Density is mass over volume. D is density, M is mass, and V is volume. The common units for density are grams per mil and grams per cubic centimeter. By the way, cubic centimeter is equivalent to milliliter. So these are the most common ones that you probably will see, but you could see any combination of appropriate units for mass and volume, meaning like kilograms over liters or kilograms over cubic meters is another one possible you could see. All right, so these are considered, I would consider these pretty simple density problems because they're very straightforward. So I will work out these three with you, and you are using D equals M over V. So I will set up my board here. Okay, so here is the setup for number one. We know the density is 3.2 grams per milliliter, and the volume is 25 milliliters. So we're solving for mass. This is your formula. So if you rearrange it, dV equals M by cross multiplying. And if you want to isolate V, for example, V would be M over D. So these are all your possible combinations. So we are using this one right here. Okay, so dV equals M. So just simply multiply 3.2 times 25 to get your mass. So you should be writing these down. So you get 80 as your mass. When you multiply these, the milliliters cancel out, so you are left with grams. And by the way, you should have a unit for every single problem when we do density. Most problems, in fact, but for all of these, we should have units. All right, number two, we're finding the volume. So if you read the problem, find the volume that 35.2 grams of carbon tetrachloride will occupy if it has a density of 1.60 grams per milliliter. For this one, we know density, again, is 1.60. And we also know the mass. So the mass is 35.2 grams. So you're going to solve for volume in this case. So if you look at all our possibilities, and you can write these all down if you want. We derive these two from this one, just rearranging to isolate variables. Finding volume is right here. We're going to take mass over density. So it's going to be 35.2 divided by 1.60. So if you plug that in, you get 22. And then remember, this is volume. So when we divide, we are going to get rid of your grams. So 22 milliliters would be your answer. That's for number two. Okay, number three was the last one. And for this, the simple ones are level one. Number three, we are solving for density. So number three, we want to solve for density. Mass and volume are given to you. Mass is going to be, or is, 2,750 grams. And volume is 250 cubic centimeters. Notice these have cubic centimeters. Remember, cubic centimeters is going to be equivalent to milliliters. All right, so if you just take density is mass over volume, you're going to just take 2,750 divided by 250. Your density in this case, just plug in 2,750 divided by 250, and you get 11. And then remember, you just divided grams over cubic centimeters. So this would be your final answer for number 3. So these are pretty straightforward. You're just going to divide or multiply. You're given 2 out of 3 variables. Just figure out that missing one. Okay, so level 2, I would consider ones that have water displacement in them. Especially with irregular objects, it's difficult to find their volumes if they're not like cylindrical or a cube. So with irregular objects, it's more sensible to use what's called water displacement method. For this method, when you're in lab, you would fill like a graduated cylinder, for example, with some water. You would record that initial volume. And then you would carefully slide the object into the container, and then the object's going to displace the water, so the water should go up, and you'll record that final volume. The difference between the initial and the final volumes is the volume of the object. So for example, we have in this picture, we have 33 mils is the final volume, 25 was the initial, so a difference of 8 milliliters. That would be considered the volume of the object. So level 2, I'm considering level 2 ones that have just one additional step. That means that they are, you probably need to subtract to find the volume of the object. So number 1, for example, we have 20 mils of water added to a graduated cylinder. The water level rises to 45 mils. There's something missing there, but this means a stone was put in there. The stone weighs 156 grams. What is the density of the object? Okay, so this level 2, we have 20 mils. Initially, it rises to 45 mils. The stone weighs 156 grams. That's the mass. Okay, the volume of the object will be the difference between the final minus the initial, F minus I. That's final minus initial. Final minus initial is the volume of the object. So if you take the difference of 45 minus 20, you get 25 mils. Okay, then you have mass and volume. Density, again, is mass over volume. By the way, I have a really cute way to remember this. Not that you have to remember it. But it's don't break my heart. So M over V. Just something I learned a while ago. All right, so if you plug that in, 156 divided by 25, you get 6.24. So your density in this case is 6.24 grams per milliliter. Make sure you report those units. All right, number 2, it says a cube of gold has a side length of 1.55 centimeters. If the sample is found to have a mass of 71.9 grams, find the density. So this one is not water displacement, but it has an additional step. So that's why maybe considering it level 2. It's a cube of gold. So cube is to find the volume of a cube. It's going to be length times width times height. So if all the sides, if it's a cube, it's going to be the same. So it's 1.55. So to find your volume, you need to cube it. So to find the volume of the cube of the gold, in this case, we're going to cube it, and it is about 3.72. And that's, I believe, cubic centimeters. Yes. So cubic centimeters. We just multiplied all three of them together. All right, so that's your volume. And then number 2, you have a mass of 71.9 grams. So they want you to find the density. That's mass over volume, which is going to be 71.9 over 3.72. So 71.9 over 3.72 is 19.3 grams per cubic centimeter. All right, number 3, the last one. We have an irregularly shaped sample of aluminum, put on a balance, find to have a mass of 43.6 grams. This student decides to use water displacement method to find the volume. They give you the initial volume reading is 25.5. When you put the sample in, it rises to 41.7. Find the density. Right, so this one, similar to number 1 of this level, they just made it a little bit longer in description. So number 3, you have the mass is 43.6. You have the volume. So the volume of the object, again, is final minus initial, which is the object. So if you take 41.7 and subtract 25.5, let's see what that is. You get 16.2. So 16.2 milliliters is the volume of your object. Density, again, is mass over volume. So 43.6 divided by 16.2. So 43.6 divided by 16.2. And you get about 2.69, and that's grams over mils. All right, those are considered level 2. I would think that level 1 and level 2 are very doable. I will do 1 of level 3 just to show you. If you would like to try level 3 because you want a challenge, they are there, but you're not necessarily expected to solve those. 1 and 2 are doable. Okay, number 3. I'm sorry, level 3, which is challenging. This is somewhere, if you're good in algebra, or you at least use it, it's probably useful in this case. So the level 3 challenging one says an irregular chunk of iron has a density of 7.87 grams per cubic centimeter. A 14.5 gram chunk is added to the graduated cylinder. If the final volume is 39.8 mils, what would be the starting volume? So in this case, you have to find one of the missing volumes, which is a little bit different than just plug and chug with your D equals M over V. So for number 1, for the challenging, you do know the density, which is 7.87 grams per cubic centimeter. You do know the mass, which is 14.5. Okay, and you know the final volume. So VF is 39.8 mils. What you're trying to find is a starting volume, which is initial. That's what I stands for. Now remember, the volume of the object is the difference between these two. So VF minus VI, the volume of the object, again, is VF minus VI. Okay, so to set this up, I would set it up algebraically. So density is mass over volume. So D equals M over V. When we say V, we're saying V of the object again. So density is 7.87. mass is 14.5. And then we don't know the volume of the object, but we know the final. So we know 39.8 minus, I don't know that, V sub I. Or you can use X if that, it's just a dot on the blue. If that makes you happier, use an X. So what I would do is cross multiply and then isolate that V sub I. So 7.87 times 39.8. You get 313.226. Okay, so that's, I'm cross multiplying because this is a equality. And then subtract 7.87 times V sub I, or X, whatever you want to use variable wise, equals 14.5. Okay, so I just expressed that, cross multiply, set it equal. And then we combine like terms. So like this is a regular number, that's a regular number. What I'm going to do is subtract this 313.226 from both sides. So if I subtract 313.226, that will get rid of that. Subtract it over here. Let's see, 14.5 minus 313.26 is negative 298.76. I'm leaving off the units for just time's sake, but remember in the end we want to have units. And then the other side would be negative 7.87 V sub I. Now they're both negatives, but if you divide a negative by a negative, it goes away. It becomes a positive. So if I divide each side by a negative 7.87, so divide it by negative 7.87, divide by negative 7.7, this will just become a 1. So 298.76 divided by 7.87, and I got 37.96 milliliters. Now, I would always make sure that that makes sense, because the initial volume should always be lower than the final volume, since the final volume is after the object has displaced. So 37.96. Oh, I'm sorry, this is the initial volume, so this should be less. So, yes. So this is less than the final volume, which is 39.8. So at least it logically makes sense, because if something was, like this was greater, then I know I did something wrong. All right, so you can try those challenging ones if you are up to that. But level 1 and level 2 should be your like base goal. So try numbers 1 through 6. For those of you in person, those are on the back, the very back. For those of you who are remote, they should be in your daily folder.